Greetings and welcome, mis amigos, mis compadres, los estudiantes de matemáticas en el mundo. We're going over factoring ax squared plus bx plus c, where I've basically got a leading coefficient that is not 1. And the first trick we used to do this was with GCF, where I'm going to see if I can make this problem easier by stealing a common factor from all of the terms. And in this case, that is doable. 8, I believe, goes into all of these numbers. So I'm going to steal an 8. And I can't steal a v because this one has no v to spare. Aw, poor negative 48. Let's see. So let's factor an 8 out. And since this is a trinomial, a 3-termed expression, inside the parentheses, there should be a 3-termed expression. So 8 times what is 8v squared? Well, that's going to be v squared. 8 times what is 8v? That's just going to be v. And 8 times what is 48? That's one of the ones that trips me up, but I believe it's 7? Because 8 times 6, no. 6 times 7 is 42. 6 times 8, no, it's 6. It is 6, isn't it? Silly Mr. Waddy. Wow, well, perfect example. I gotta practice my my times 6s, I guess. Maybe I'll do that later. Maybe Sal Khan can help me out. Help me with my times 6s, Sal. All right, here we go. Now, this is factored out by the GCF, but it is not fully factored. It turns out the inside, this trinomial, can be factored further. So I'm going to find the factors of 6. And in this case, because the 6 is negative, I want the ones that subtract to be the b term, which is 1. And 1 and 6 have a difference of 5. 2 and 3 have a difference of 1. So those will be the ones that I pick. So I'm going to have 8 still out front, multiplied by, and now this trinomial, I'm going to write as the product of 2 binomials. I'm unfoiling this. Foiled it. And so I'm going to have a v with a 2 and a v with a 3. Let's see, to figure out their signs. They multiply to be negative. So their signs are either plus, minus, or minus, plus. And it looks like they've got to add to be a positive, so the more influential the 3 must have been positive. So minus, plus is the solution. Well done. All right, so that's the first kind where you were able to GCF and then conveniently were able to factor this because the v had a 1 coefficient there. But what about when that doesn't work? Bump, bump, bump. Craziness, right? Yeah, it's crazy. So let's try to figure this out, friends. I gave you some steps. Your book recommended a process that was very much guess and check, which does work, but you might be guessing and checking a lot before you come to your conclusion. So let me throw up my steps right here. All right, so this is what I said. All right, and so we're going to do this together. That way my internet friends who are just watching this homework video, they know which steps I'm talking about. So factoring when AC is positive. So step 1, all right, I've got an A term that's not 1. What I do is I multiply the A times the C. All right, 8 times 7. That one's 56. I should have known that from earlier. Man, craziness, am I right? All right, so that's step 1. And now I'm going to find the factors of 56. 1 and 56. 2 and, let's see, 25 plus 3, 28. 3, no. 4, yes. 4 goes into 28 7 times, and then 7 times 2 is 14, so 4 and 14. 5, no. 6, no. And then 7 and 8. All right, and my goal here is, since 56, positive 8 times positive 7 was positive 56. Actually, let me write AC here. AC was equal to that, just so people know where that 56 came from. And since this is positive, I want the factors that add to be 30. So this would add to be 57. This would add to be 30. This would add to be 18. Wow. I know, but I just wanted to show the idea of adding these. So it looks like 2 and 28 is what I get. So, right, find the factors of AC that add to B. Add to B. All right. And now the trickiest step is this one, step 3. Split the b term into two like terms whose coefficients, the numbers in front of them, are the factors that we just found, the 2 and the 28. So let's see, what does that look like? So I'm going to have 8m squared still hanging out. And I'm going to have a 2m, all right? Since these are like terms, they've still got to be in terms of m. And 28m, and then plus 7 still hanging out. Now I've got to figure out the signage for these. Now they multiply to be positive, okay? So that means my options are plus plus or minus minus. And they have to add to be positive 30. So what do you guys think? Plus plus? I think so too. He knows so. That's even better. And like earlier, I only thought that like 7 and 6 multiplied to be something, and I was wrong. But that's okay. He knows so. All right, so I've split the b term into two like terms, giving me a 4-termed expression. And the next thing I'm going to do is called factor by grouping. All right, and this is what I do. I factor out the GCF from these first two terms. So between 8 and 2, right? You with me, Brandon? You writing this down? I could steal a 2. And between m squared and m, I can steal an m. Okay, and tell you what, we'll look at this right now as well. Between 28 and 7, I could steal a 7, and this one has an m, but this one doesn't, so I can't steal that. And I'm stealing a positive 7. This one will always have this sign with it. And it doesn't seem as important when it's plus, but it's super important when it's negative, that you factor out a negative if your first term in your GCF expression is negative. Yeah, well, you'll notice it like pretty quickly once you get to the next step. So let's see, factor out a 2m from the first two terms. So that's going to be 2m times 4m plus 1 plus 7 times, let's see, this is in a parenthesis. A z, oh, that's a 2, sorry, and that's a 2 as well. Sometimes my 2's look like z's. And that's why when I write a Z, I try to put the cross on it there just to distinguish it more better. Let's see, 7 times what is 28? Well, that's 4, and it needs the M. And 7 times what is 7? That would be plus 1. And what did I tell you guys yesterday about these parentheses, these binomials here? They have to be the same. If those aren't the same, you should just push the brakes and be like, all right, what happened here? I did something wrong. So, yeah, those got to be the same. And so what we end up doing is we write the duplicates in one set of parentheses, and we write the GCFs in the other set. So 2m plus 7. All right, which step did we lose you on? Is it, or yeah, which line? Line. Okay, got that. Step 1. How about splitting the b term? Step 3. All right, so it's probably the factor by grouping is where you're off. Like, do you know how I got this 2m? All right, so when I was looking at these first two terms, I was trying to find the thing that I could take from both of them. So what's a number that goes into both 8 and 2? 1 goes into both of them, but that's not the greatest of the common factors. But 2 was the greatest number, the biggest number that goes into both 8 and 2. And 28 and 7 is 7. So that's how I picked those, and I factored those out. So one of the things I would recommend if you want to practice just that step is search for the phrase greatest common factor, GCF, greatest common factor, and either in my videos or in Khan's, you know, and he'll be able to help you out, or we'll be able to practice that during an ACE block as well. Aha, okay. So once I get the 2m out here, now I ask the question, if I was to distribute, because I'm undistributing when I did that, 2m times what would have equaled 8m squared? And 2 times 4 is 8, and m times m is m squared. And 2m times what would have equaled 2m? Well, 2m times 1 is equal to 2. So you kind of have to, or you can ask it in the other way and just do 8 divided by 2 is 4, and m squared divided by m, which we haven't talked about that property of exponents, but that's equal to m. Or like 2m divided by 2m is 1. So there's a couple ways to find those numbers inside. But that's what I would recommend, is just practicing some of the GCF problems is what I would recommend, which I think, we might have some practice problems like that in 7.4, maybe? 7.5, maybe the beginning of 7.5. All right, but we're going to call it a break here, internet friends. Thanks for watching. Have a great day.